Hey guys, I gotta tell you about this incredible science topic. So, as you know, when humans travel to space, astronauts face serious health issues due to the extreme conditions, especially the reduced gravity. Well, two Buck scientists and their team have, for the first time, revealed how this lack of gravity affects our immune system cells at the cellular level. These scientists, led by Christopher E. Mason, Ph.D. from Weill Cornell Medical College, David Furman, Ph.D., and Daniel Weiner, MD, have done a comprehensive study on how gravity impacts immune cells. They even identified space nutraceuticals that can counteract the negative effects of microgravity on these cells. This work got published in Nature Communications. Weiner said, "We show how simulated microgravity shapes immune cells and how the changes in force alter the cell's function. This level of detail is new and super exciting for understanding microgravity's effects on cells." Using cells in simulated microgravity, combined with data from astronauts and mice on the International Space Station, the researchers mapped out how the different immune cells in peripheral blood change when gravity is reduced. These cells include lymphocytes and monocytes, which are key players in our immunity. The study is super important because the changes observed during space travel resemble those that happen during aging on Earth. Plus, they've identified compounds that can reverse the effects of near-zero gravity, like quercetin, which shows promise for mitigating damage caused by spaceflight and normal aging on Earth. Furman said, "Our work provides a resource to better understand how and why the immune system changes in simulated microgravity and spaceflight. They're also paving the way to develop measures to maintain normal immunity under these harsh conditions." Astronauts in low Earth orbit, like on the International Space Station, deal with immune system problems such as infections, latent viruses reactivating, and skin sensitivity, even on short-term missions. Previous studies found that various immune cells' functions are impaired in actual or simulated microgravity conditions. But the fundamental mechanisms, genes, and pathways that explain immune dysfunction in microgravity were mostly unclear. The researchers wanted to understand what was happening on a cellular level. Led by Buck postdoctoral researcher Fei Wu, Ph.D., and grad student Huishan Du, the team examined how 25 hours of simulated microgravity affects the human peripheral blood mononuclear immune system using samples from 27 healthy donors aged 20 to 46. To simulate a nearly zero-gravity environment, they used a rotating wall vessel, a device developed by NASA. They used techniques like sequencing and super-resolution microscopy to explore the changes caused by reduced gravity. Then they validated their findings by comparing their data with other space studies on humans and mice, including the JAXA Cell-Free Epigenome Study, Mission, SpaceX's Inspiration 4 mission, NASA's Twins study, and spleens from mice housed on the International Space Station. Weiner, whose interest in space medicine came from studying how environmental forces affect immune cell function, said, "Changes in mechanical forces appear to orchestrate immune cell function." Parts of astroimmunology are related to this emerging field of mechanoimmunology. After identifying several genes and biochemical pathways affected by microgravity, the team wanted to find specific drugs or supplements to protect immune cells. Using machine learning tech developed by Furman, which detects over 2 million interactions between genes and different drugs and foods, they identified dozens of potential compounds. One of them, quercetin, found in red onions, grapes, berries, apples, and citrus fruits, reversed about 70% of the changes caused by lack of gravity and protected cells from reactive oxygen species excess. Weiner said, "These findings define hallmarks of immune cell alteration in simulated microgravity, with correlation to spaceflight exposures in mice and humans." This work is setting the stage for future research in mechanoimmunology and astroimmunology and provides opportunities to develop countermeasures to maintain normal cellular function in space. Furman added that this publication sets the standard for analyzing physiological changes that come with space travel, calling it the first comprehensive study providing a global scientific community with an atlas to understand human biology in these extreme conditions. The implications are huge beyond just humans in space. The researchers are excited to explore similar changes happening in aging humans on Earth, aiming to design interventions to potentially reverse the immune dysfunction that accompanies aging.